Hello, everyone. I'm Hannes Mueller. I'm one of the principal investigators between the EconAI research group.
And I'm Ben Seimon. I'm the lead data scientist at the EconAI research group.
So we're gonna present something to you that we developed at EconAI, kind of in the conflict forecast capacity we have, and this was developed for and with the German Federal Foreign Office and UK Foreign Commonwealth and Development Office. And so let me first tell you something about our research group. Um, we are a group of data scientists and economists. And so the principal investigators are Laura Majoral, Christopher Rau, and myself, Hannes Müller. And then you see, data scientists that work for us here on this picture. And so what do we do? We work mostly on conflict forecasting. Um, and all this is kind of available at the conflictforecast.org webpage. And this page was developed, as I said, for FCDO, GFFO, but also with the Spanish Research Council, CSIC, and the Spanish Central Bank, and several other organizations that helped us develop this webpage. And then we are also developing additional systems right now for the GFFO on forced displacement and denuclearization, but kind of like an entire different arm is in kind of providing decision-making support where we kind of try to use these forecasts. And so this is kind of the spirit of this project that we're going to present today is kind of between forecasting and trying to think about decision support and kind of the thing we're most excited about is what we're going to talk about next.
So, when we were working with the FCDO, we've done multiple projects with their team, and the most recent one is to develop forecasts at the admin 2 level. So, this is a very high level diagram of the process. So, the start is the data pipeline, which is arguably the most important step. So first, we have geospatial events. So we're looking mostly at UCDP and uncleared conflict data. Um, Geospatial events here, you see we have this kind of blue admin region in the middle, and then green, a slightly lighter green, and then an even darker green with the red dots. So this is us trying to capture spillover effects. And this is at this kind of unit is one of the most important parts of developing a good forecasting system. Secondly, we have 6 million newspaper articles. So we are working with newspaper articles from the BBC World Monitoring, The Economist, Associated Press, New York Times, and Latin News to get some South American coverage. Essentially, what we're doing here is geolocating the articles to admin 2 regions in order to track the news landscape at any given time. The idea being that if increased text and reporting on certain topics like military conflict might be a precursor to conflict. In the same way, we may also see things around economics or health, which might be a precursor to decreasing risk. Finally, we have population data and environment data. So environment data relates to temperature and precipitation. Elections is a really novel addition to this forecast. So we hand created, thanks to Renato in our team, we hand created a data set of elections going back to 1989 at the national level. And it's also one of the few features in our data set that is forward looking because we do know when elections might be in the near term future. Finally, gender equality, this relates mostly to the sexual violence forecast. Then here's the techie ML part. We move into tree-based machines. So we rely on kind of classic tabular machine learning algorithms for this particular task. We're relying on CatBoost. There you see a very, very high level non-techie version of how a decision tree might work. So it splits the data on recent violence, and then it would split again on conflict news. Yeah. And this model basically gives us predictions of whether a certain event might happen in the next 3 to 12 months. So let me talk a little bit about the data set we're using. So here you see on the left-hand side, riots as appearing as blue dots and battle fatalities appearing as red dots for Nigeria. Yeah. And on the right-hand side, you see where we are geolocating newspaper articles. Increased red means that that article is talking a lot about a military conflict. The military conflict topic is made up of lots of words such as violence, targeted, weapons, soldier. And what you see very clearly here is that in the northeast of Nigeria, we have kind of increased battle fatalities, and we also see kind of a darker red on the newspaper articles. So more news reporting in places where there is more violence. The most important part, probably, of our forecasting method is this, what we call the pseudo out of sample or rolling forecast. So the main objective of any machine learning model is to build and predict outcomes well on future unseen data. The only way to assess how your model will truly perform in out of sample is to mimic the policymaker's information set at any moment in time. So what you see in this kind of plot are these blue dots and red dots. So this is just looking at 1 year of data. It's kind of a bit of a silly example, but if we were training a model for just 1 year's worth of data, the first split would train on 2024-01, so January up until September, to predict an outcome that might happen in October. We would then go again and train in the second split on all the data from January until October to predict what might happen in November. So we do this all the way from starting from January 2020 all the way up to the present. So we're always trying to simulate what the policymaker would have known at that time to make a forecast. So in the end, we generate predictions for 3 outcomes globally. So we have any violence, any riot, and any sexual violence. This means, will there be any one of these events in the next 3 or 12 months? And we're now updating these models monthly, and we make them publicly available and are free to download at conflictforecast.org. So I'm going to walk through a little case study here just to give a sense of how this might be used in practice. So we have here, you're looking at Honduras. These are the admin 2 units for this country. The shading of red is the predicted probability of any riot in the next 12 months as at January 2021. So we're simulating the information set available to the policymaker at January 21 and forecasting forward for the next 12 months. The deeper shades of red indicate a higher predicted probability. The lighter shades of red, a lower probability. So how would we use this in practice? First, we would need to binarize our predictions. What does this mean? This means the probabilities range between 0 and 1. We need to set a cutoff for which we would raise a flag. So on the right-hand side, you see this for a given threshold. We say, okay, anything above that threshold we're going to raise a warning. Okay, so these red shaded regions are the regions that we're highlighting at high risk, and we're going to pretend as if there's no risk in those unshaded regions. Okay, and this is how we can evaluate the performance of our forecast. So again, we have the predicted probabilities in the top left, the binary predictions in the bottom left, and then we have what actually happened in the next 12 months. And you see that these binarized predictions match up fairly well to the actual instances. Okay, but a more rigorous way of doing this is with a confusion matrix. Okay, a confusion matrix basically looks at the predictions versus what actually happens. So the dark shade of green here means we predicted a riot and it actually happened. The light shaded green means we predicted no riot, so it fell under our binarized threshold, and there was actually no riot. Then we have these 2 types of error. Okay, we have false positives. This means that we predicted a riot, but nothing actually happened, this kind of lighter orange. And then we have this dark orange, which we call a false negative. We predicted no riot, and in fact, a riot did materialize. So you see from our map, we make some mistakes, but generally we're doing quite well in the country. So we're predicting riots in these kind of bigger admin 2 units. And then we have some false positives in kind of adjacent regions, and then some false negatives towards the northwest. For the more techie amongst you watching this video, this is a precision recall curve. So this looks at basically how well our model performs in the aggregate across the whole globe for all admin 2 units over our full test set sample. How well do we perform under different thresholds? So The first thing to note is that our any violence forecast is the best performing, any right next, finally the sexual violence, and that also we do better with a longer forecasting horizon. So the 12-month ahead forecast is better than the 3-month ahead forecast. So what are the key lessons learned from this project? Well, the first one is that spillover effects are crucial when generating prediction models at this unit. Good feature engineering for spillover effects makes a very, very big difference to the model's performance. So what, again, for the more techie amongst you, we consider a buffer around each admin 2 region, and we are looking at events that happen within this buffer. So within 25 kilometers, within 100 kilometers, all the way up to 500 kilometers. The second thing is that scaling is hard. This was a real learning for our team. This was only a 6-month project, and we're used to doing forecasts, production level forecasts at the national level. Now, you only have 200 countries here, whereas we have 49,000 admin 2 units. So when you get to experimentation, you need to be much more efficient, and also when you're forecasting with that many units, the time it takes to run is significantly higher. Finally, predictions are informative. So this product was actually born out of demand from the policymaker side. One, for global updates, so they can make cross-country and within-country comparisons, but also regularly updated future outlooks. So we're updating every month across all 3 outcomes.
So now I'm going to talk a little bit about kind of what is the use case, how is this actually used by the governments that we work with, and what is our view on where it could be useful and is not used yet. So let me first say that our experience in the last 5-6 years of conflict forecast was that there's a growing interest in forecasting and using forecasts, but that very often organizations are still adapting to this new kind of data that we have, right? And I think that I want to stress this. You can download these rolling pseudo out of sample forecasts as data from our webpage. So you can not only get our newest predictions, but every month we update a kind of what would the model have guessed is the best kind of view forward, starting for the national level from 2010 January to now, and for the subnational level from 2020 till now. For every month we provide, for every unit that we're forecasting in, we provide what the machine would have predicted at the time, right? And what this is useful for is for thinking about prevention. Kind of predicting where and when conflict may erupt helps target early interventions. And you can think, as an organization, you can think about, if we had this signal, if we had already kind of introduced these signals that are coming from conflict forecast into our data stream and into our thinking about countries and which countries were at risk at the time and what we thought about at the time, you can then also think about, is there an added value to you organizationally, right? And we think that this kind of, before conflict breaks out, these kind of predictions are less precise, but they are especially useful in policy areas that are right now not yet including this conflict view. So very often in development, people are mostly concerned about economic growth or inequality, but they might not be necessarily concerned about political equilibria that are happening on the ground. And so taking on this view locally and nationally about what kind of is the risk of conflict at this moment, and has this risk escalated in some area or at the national level recently, is perhaps very useful. And kind of with the best kind of indicator we have of this is our collaboration with the IMF actually on this, where the thinking about macro policies and the effect of macro policies and the context to macroeconomic policy advice is sometimes that of armed conflict. And of course, the IMF goal is not to prevent conflict, but macroeconomic stability. But of course, if you ignore conflict risks, then macroeconomic stability is in danger. And so therefore, even in circumstances where you're not necessarily concerned only about conflict, it might still be useful to take conflict risks into account. So this is the first kind of aspect. The second one, and this I think is particularly useful for the admin 2 forecast, is even if you're just monitoring violence and you're not necessarily interested in like the 12 or 3 months ahead view, you might still just kind of look at a forecast as a summary, as a very smart summary of the situation on the ground, using many, many factors and kind of putting them together in a meaningful summary, right? So think of a forecast just as a data summary of the election data, the population data, the news data, and the violence data, all bundled together into a single number to kind of summarize the situation in your region, but also in neighboring regions, right? And I think this is helping people that are working on the ground to kind of get a quick overview over the situation on the ground. And we think, therefore, the kind of the admin 2 forecast, even if you're not interested in the forecast, smart trend summaries. And then kind of this leads on to conversations we think people could have into thinking about whether something they're implementing might help. The problem with implementing policies for conflict prevention and humanitarian aid and de-escalation is that we usually don't have a good counterfactual, right? And many experts are struggling to make sense of a very complex world. And so because you can add to causal models and you can add to what the expert does, so this is where kind of the first 2 points kind of come to. You can also think about the policy impact, so it's the 4th point now, and kind of build a counterfactual of a region that had similar conflict risks and now is de-escalating thanks to what you did there, right? Or kind of think about a country where you are kind of trying to help build a power sharing agreement, and you can compare that country to another country that had similar risk at baseline, and you can compare your policy impact over time in this way. And we think that tracking countries over time and tracking regions over time is very useful in this way. And then finally, we think that having this conflict data available, organizations that we work with to collect and archive their policy data can help build a stronger case for some of these policies, but can also help critique some of the decisions that have been done in the past. And we think that having forecasts, therefore, is kind of something that helps the entire environment, both locally in these conflict-affected countries, but also for outside organizations like the foreign offices we work with to kind of build sharper policy tools, better forward-looking policy views, and also critiquing their own decisions in the past. So we really hope that it has a kind of a general equilibrium effect on how we think about armed conflict and deal with it. So thank you very much for your attention. And this is goodbye from the 2 of us. See
Thank
you.
you.